Hello dear students, welcome to ECE Academy Benefactor. In this class we will be seeing realization of multiple output function using binary decoders. Okay. So, we can have two conditions, one is for active high output and the second one is active low output. So, we will be seeing how under two conditions, active high output and active low output, how to implement multiple output functions using a decoder. So, again in active high output we can have the function in SOP form, that is sum of product form, or the function can be in POS form, product of sum form. So, what is the topic today? Realization of multiple output function using binary decoder. So, how many conditions are possible? We can have active high output or active low output. For active high output, again the function can be in the SOP form or POS form. And the second topic is for active low output. For active low output also the function can be again SOP form, the function can be in the SOP form or POS form. Okay, so let us see now for active high output for SOP function. So, how do we know the function is SOP or POS? If the function is given as f is equal to summation of 1, 2, 3, 4, 1, 2, 3, 7. Summation means list of minterms. List of minterms means it is a SOP function. Another function is of type f is equal to pi of 1, 3, 5, 7. So, this pi indicates list of max terms. List of max terms means it is POS function. So, SOP function is denoted by summation and POS is denoted by pi. So, we need to implement this function 1, 2, 3, 7 using a decoder. So, the highest number is here 7. 7 means what type of decoder we need to use? It will be 3:8 decoder. In 3:8 decoder, 3 inputs and 8 outputs. So, you can have the outputs as y0, y1, y2, y3, y4, y6, y7. So, the largest number is y7. So, depending on the largest number used, you can decide the decoder. So, here it is 7. In a 3:8 decoder, the outputs are varying from y0 to y7. So, 3:8 decoder is enough. So, we need to implement this function 1, 2, 3, 7. What we will do? 3:8 means 3 inputs. So, we have taken 3 inputs as A, B, C. These 3 are inputs. To enable the decoder, we need to connect an enable input. Now, coming to the outputs are y0 to y7. The list is from y1, y2, y3 and y7. These 4 outputs are connected to an OR gate to generate the function f, to generate this function f. So, this is how we implement for active high output in SOP form. Let us now see the POS form. Here the list is given. So, 3:8 decoder, 3 inputs A, B, C, enable the decoder by enable input, 8 outputs y0 to y7. The outputs are y1, y3, y5 and y7. These outputs are connected to a NOR gate to generate the function f. So, in SOP form we are connecting the list, what is connected the output to the OR gate. In POS form the outputs are connected to a NOR gate. These two conditions are for active high output. So, for active high output we are using OR gate or NOR gate. If it is SOP form OR gate, for POS form NOR gate. Now let us say for active low output, when the output is active low, how to implement using 3:8 decoder, or how to implement using a decoder. So here the function is given as summation 1, 2, 3, 7. Summation means it is an SOP function, it is SOP function. So 7 is the largest one, so definitely 3:8 decoder is enough. So for active low output, we need to connect at the output bubbles. Bubbles means they are active low. At the input we are having A, B, C, these are inputs. 3 inputs. To enable the decoder we are having the enable input, and output is 8, Y0 to Y7, and how they are? They are active low. So now the function is 1, 2, 3, 7. So we are connecting 1, 2, 3 and 7 to a NAND gate to generate the function f. So for active low output you have to need to remember that at the output you need to connect bubbles, and you need to give to NAND gate for SOP function. Coming to POS function, it is given as f is equal to pi 1357. So we need to go by 3:8 decoder, 3 inputs A, B, C, one enable input to enable the decoder, and the outputs are Y0 to Y7, and it is active low, so bubbles are connected at the output. The function is Y1, Y3, Y5, Y7 are connected to AND gate to generate the function f. Okay, so in this way we can implement the multiple output functions using decoder. So what is the conclusion here now? So when you are implementing decoder, we can have two conditions. One is active high output, and in this also the function can be SOP function or POS function. So SOP function is denoted by summation sign, and POS is denoted by pi, list of pi, max terms. And here we use all the outputs are connected to OR gate. For POS form, all the outputs are connected to NOR gate for active high output. The second condition is when the output of the decoder is active low. When the active low, it can have two conditions, SOP and POS form. SOP is symbolized by summation sign, POS is symbolized by pi. For SOP form, we need to connect it to outputs will be active low and are connected to NAND gate. For POS form, the outputs are low and are connected to AND gate to generate the function. Okay, so in this way we can implement the decoder. So it's easy, if it is not mentioned in this question whether to go for active high output or active low, you can go for active high output. If it is SOP form, connect it to OR gate, and the list, if it is POS form, connect this list of max terms to NOR gate. I hope you have understood the class. If you have any queries, you can post in the comment section. Thank you. Good luck, students.